Thanks for the introduction and also for the opportunity. This is the first time I actually ever attend Kamailio World. It's been really exciting so far. So I hope I'll be able to live up to the expectations for my talk as well. And yeah, I'm going to talk about Janus today. So it's a Webrtc Gateway, and I'll try also to focus a bit more specifically on SIP usage, considering it's probably most interesting for you. And this is a very quick agenda that I'll go through. I'll just go through some brief context on Webrtc in general, because I assume that most of you will already be familiar with that. And then I'll move on to describing a bit the Janus architecture, how you can actually use it with the SIP infrastructure, and also maybe some details about who is using it today and how, basically, in order to do some cool things. So before we start, actually, a few words about us. We are actually a company, Mitico or Miteco, or however you want to call it. We are an academic spin-off at the University of Napoli. We all got our PhD from there. Our professor is also one of the co-founders of the company. And we come from Napoli, which, if you've never been there, looks pretty much like this. And our office is a tiny pixel over there, very close to the shoreline, which is nice. And our focus has always been on real-time multimedia applications since the very beginning. In fact, I worked on my thesis on asterisk and multimedia conferencing, especially at the time it was within the ITF, when they were working on the so-called XCon, centralized conferencing framework. Then we moved to media control, which was a framework to actually handle application servers and media servers to allow them to communicate with each other and create fun stuff. So then we tried to widen the scope as much as possible to not only do conferencing and things like that, but to, let's say, cover multimedia, real-time multimedia interactive applications in general, and by still, of course, keeping standardization very much in mind, because we believe this is a strong point. And that's why Webrtc actually proved to be an excellent opportunity for that, and which also helped the genesis of Janus. And of course, as a small company, there are several things that we do for a living. So we do, that for a second there, okay. We do consulting activities, commercial support, pretty much anything, or any of those things that small companies like us, like ours, do. And so, I mean, in general, if you're not familiar with Webrtc, it's pretty much an attempt to standardize a solution in order to provide and implement real-time multimedia applications within a browser natively. Because you may remember that in the past, you had to rely on stuff like Adobe Flash, Java applets, or on any kind of those things that were really hard to maintain, both for those who developed them and for people who actually wanted to use them, because you had to take into account cross-platform versus cross-system differences and so on. It was really a nightmare, which is why eventually the Internet Engineering Task Force and the World Wide Web Consortium, the two main standardization bodies when it comes to the web, actually decided to work together on a new effort that was exactly the Webrtc specification. And more in particular, the ITF works on, defines anything that actually travels over the wire, so the formats, the protocols that are involved with further communication, while the W3C takes care of whatever is happening more on the end side, so whatever is happening at the HTML and JavaScript level, so providing the APIs to use all of these as well. And from an architectural perspective, Webrtc was conceived to be peer-to-peer. So you have two users that want to actually communicate with each other. They still rely on a central point that is typically a web server. You go on a web page and you decide that you want to have a call with each other. They exchange some information, and we'll see that it's exactly SDP, even though it's SDP on steroids, we might call that, because there's a lot of stuff that is happening there besides what is usually happening with SIP infrastructures. And eventually this leads to a peer-to-peer communication between the two users. So the web server gets out of the way after the setup phase, and people can just communicate using secure RTP, and more specifically involving stuff like DTLS and ICE, which are things that are, let's say, mandated by Webrtc right now and may not be available in all SIP infrastructures. The nice thing about this picture, though, is that you can actually, one of those two parties that are involved in the communication does not need to be an actual person. It could be an application of some sort. And for instance, it could be a Webrtc Gateway, which more or less in general needs to take into account the need of either just taking care of the signaling part. So maybe in Webrtc, there's no mandatory guideline for the signaling protocol to use. You can use pretty much whatever you want. You just have to stick with SDP. And so if you want to communicate with something on the other end which does not talk WebRTC, you have to take that into account. And typically, you also have to take care of whatever is happening in the media layer, because I was anticipating that WebRTC makes use of innovative stuff like DTLS support for setting up secure sessions. It mandates ICE support and things like that, which may not be available on legacy infrastructures. In that case, we have a legacy phone that just talks plain SIP, plain RTP, and so on, and you have to adapt that somehow if you want those two parties to interoperate with each other. And more in general, you can generalize this kind of approach and assume that the Webrtc Gateway in general should be able to, let's say, adapt to different technologies in the backend. So maybe you want to reuse some Adobe Flash Media Server that was in the backend and want the Webrtc users to be able to communicate with that. You want to access security cameras by means of RTSP and things like that. These are all use cases that are very much alive, and so in principle you can assume that a box like that can actually help you covering that scenario, or maybe you just want to do anything within the Webrtc Gateway to do, for instance, Webrtc media conferencing and things like that. So I will not go into the details about why, whether or not this component could be actually useful or not. I sent you to this small blog post that I wrote on the Webrtc Hacks blog some time ago, which describes a bit the pros and cons of this kind of approach. We assume that since I'm presenting here, we find it useful, and so I'll just move on to presenting our attempt to do something like this. And more in particular, we call this effort Janus. And as Daniel was anticipating, Janus was the Roman god that, of transitions, of beginning and transitions. And more in particular, it always looked both at the past and the future at the same time, which incidentally is why the month of January is called like that. And for these reasons, we chose this name for our project, because in our view, we wanted to always have a look at the legacy technologies, where by legacy we mean whatever existed before WebRTC or already existed and you wanted to reuse for some reason, and that's the past. And the WebRTC was always the future in our sense, so it made sense to call the project like that. And it's an open source project, so you can just go over that link over there. That's the GitHub repository of our project. We also have some demos and documentations online if you want to play with it and have a look at that. Both are actually generated and available directly within the repository, which means that you can actually just get the project compiled by yourself and have both in your systems. We just have those there for convenience if you do not want to install anything from scratch, but just have a quick look through the demos and stuff that is available. And we also have a fairly active community as a Google group, basically, where you can interact with other people, maybe solve issues, try to understand how to deploy things, and so on. And the way we wanted to do that, and the way that we actually did that, was by following some kind of a modular approach, and something that could be as, let's say, extensible as possible, because we didn't want to, let's say, create something that could be used for some use cases now and then rewrite everything from scratch maybe a couple of years from now when new use cases emerge, and then we had to change things, too many things. So we wanted to have a core that was actually just responsible for the WebRTC stack, and so that would implement the whole WebRTC specification, which has a huge number of protocols that you need to implement in order to be able to interact with browsers. So the core takes care of that. Then we have a modular approach for different transports, because of course, in order to talk to Janus, you need to talk the Janus language, which is basically a Janus API based on a JSON protocol. And we have different transports in order to talk to that, so you can use HTTP, WebSockets, RabbitMQ, and Unix sockets, and so on. And of course, if you expose HTTP and WebSockets, this means that you can actually talk to Janus directly from within the browser, which is what the demos that I mentioned before actually do. And then the actual logic, so what you want to do with this media, so if you want to do conferencing, streaming, or whatever else, is actually not part of the core, but is part of different plugins which actually implement this kind of logic. And so the idea is that users attach to these plugins through the core, so they establish a WebRTC connectivity, then they talk to these plugins in order to, let's say, establish any kind of communication that they want to have with that. And then once you create a peer connection, the core handles the WebRTC stuff, and the plugins only have access to plain RTP that then they can use, manipulate, forward, and do whatever you want with that. And in principle, we have some proof of concept plugins that we have implemented that try to cover, let's say, most of the use cases that are typically needed. So we have a plugin that does echo testing, a plugin that does streaming, so a plain RTP to WebRTC broadcasting and translation, a video room that is basically a selective forwarding unit, and a SIP gateway, of course, because we wanted to be able to interact with legacy SIP infrastructures and things like that. And this is a quick image that just shows you pretty much what I've said by words right now. this is an example of a browser talking through the HTTP transport and exchanging Janus API messages with the core, establishing two different peer connections that are basically two different media channels with Janus. And then these two channels can actually be attached to different plugins so that you can actually interact with different plugins at the same time within the same application. And one of those plugins may involve communications with the outside world using different technology and so on. One other, for instance, may not, because you're just going to record things locally, or maybe because you're going to do a plainly Webrtc conference, and so everything is going to stay in the loop and things like that. And in order for this to work, of course, this only works if you have an extensible mechanism for also talking to these plugins, because, as I mentioned, the user actually talks to the plugins directly in order to establish whatever kind of communication mechanism that is needed, because, for instance, conferencing will have some requirements. You'll have to have stuff to say, I'm going to join, I'm going to leave, this is my username, and stuff like this, while streaming may have different requirements. And so each plugin can actually implement its own protocol. The core really doesn't care about that. And at the core specifically, the Janus API, in that case, acts as a transport for the communication with the plugins themselves, which means that then we can have, let's say, some way of having a custom header that allows us to then exchange these messages in an opaque way to the core, but then allows us to do extensibility the way that we want, because then we can just write a new plugin tomorrow that will talk its own language. Users will be able to talk with it without changing anything in the core itself. And there are, one thing that I want to stress out is that each plugin, as I've described it so far, we've conceived it mostly as a feature and not as an application. So when I mentioned, for instance, that we have a plugin that can be used for conferencing purposes, so let's say a selective forwarding unit, this doesn't mean that that plugin is the conferencing plugin. It means that that plugin can actually be used to let's say, broadcast a WebRTC source to several different users at the same time. And so you may want to use it in a conferencing application, but you may also use it in several different kind of applications that actually rely on this kind of relationship. So we basically see these, each of those plugins mostly as a feature, as I said, and mostly as a brick to actually build a more complex scenario. So the idea is that you have all of these plugins, and then you can actually try and combine them in order to create a much more complex application than the individual plugins provide, so that eventually users have actually a much richer experience in their own web page. Because, of course, users do not need to know that they are actually interacting with different plugins and things like that. They only see media coming in and going out, and several different streams that are being involved and composed within a web application and so on. They just see these, which is an aggregation of all of these features, also with features coming from third-party stuff. So you may involve other components from other vendors that do completely different things, all to build a much more complex house, let's call it like that. And these are a few examples of how you can combine them. I made just a very quick list that shows you some of the things that you might do. And rather than going through this list in let's say, in a text way, which may not be that fun, it may be more interesting to have some, let's say, more visual examples. And one of those may be, for instance, you want to do some kind of an online webinar with the possibility for remote users to make questions and the speaker to give answers and stuff like that. So you may want, for instance, to rely on the video SFPO plugin for anything that involves video, so that you have, let's say, the user captures his webcam and forwards it to all of the people that are interested in watching it. He does the same for the screen sharing, so that he can, let's say, broadcast his own presentation. And then for audio, we rely on a different plugin. So you may either rely, for instance, on the Audio Bridge plugin, which is basically a WebRTC audio mixer that is available as one of the plugins in Janus. Or you may use also the C plugin for the purpose, so that you can actually just have the C plugin forward to an external conference bridge, so that you can actually handle the mixing parts within an external conference bridge, and then you just have Janus act as a means for accessing that component, so that you can also have, let's say, people joining in from using SIP softphone or regular the PSTN or whatever you actually want to do with that. And another nice example that we typically make is also the social TV application, where by social TV I mean basically you have a web page that shows a TV channel of some sort, and then the TV channel you can actually watch together with your friends wherever they are. And the idea could be something like a TV live broadcast that is actually generated using the streaming plugin. So maybe you have an FFmpeg or GStreamer script that is actually generating, capturing the TV feed in a legal way, hopefully, and then actually broadcast it to Webrtc via Janus. And then at the same time, you're actually also relying on the conferencing, the SFU plugin, in order to have you and your friends interact with each other and maybe watch the TV match together, be happy when your team scores, and let's say insult each other when they don't and stuff like that. And these are, let's say, just a couple of examples about that. And one other thing that I wanted to highlight is that we also have, of course, whenever Webrtc is involved, not everything always goes, it's not always a sunny day in the Webrtc world, let's say like that. And so things can go wrong at different levels. The handshake in DTLS may fail. You may fail to get a connectivity at all using ICE and things like that. And so it might be useful to just inspect the Janus internals to figure out what's wrong, because browsers themselves expose this kind of information using the so-called internals, for instance, both Chrome and Firefox do. And so we wanted to provide something similar within Janus itself, which we call the admin API, which is basically a way to poll Janus, to interrogate Janus and get information about the specific internals of a communication with a specific plugin instance. So in this case, for instance, we are interrogating a so-called handle, which is an abstraction of the peer connection between a user and a specific plugin, which is being attached to the EchoTest plugin. This gives us some information related to the internal specifics of the plugin itself. And then you have all below, that is not passed just for brevity, you have all information related to the actual Webrtc stuff. So you may have a look at why, for instance, a peer connection failed to start. You may check whether or not there's any data flowing in and out, if the ICE and DTLS stuff went fine, and things like that. And if you want to learn a bit more about this, we have also a blog post over here that tries to explain a bit how you can actually study an admin API dump in order to figure out what went wrong and why. So at this point, you may be wondering how Janus would actually be of use to talk to a SIP infrastructure more specifically. And as anticipated, we actually wrote a SIP plugin within Janus that is available among the plugins that we provide out of the box. And we also have an online demo that you can play with. It basically allows you to register at a server and then make or receive calls from a SIP endpoint on the other end, whether to involve audio and video and so on. So I encourage you to play with that if you want. And it's basically a Webrtc To Sit Gateway. And the idea and what we did was basically to have Webrtc on one side, and basically the plugin acts as a SIP endpoint on your behalf within the server itself. And so you can do plain SIP or RTP, or you can involve also security at either just the signaling level or also at the media level as well. And as I was saying, in that case, that specific plugin acts as a SIP endpoint, and specifically it was implemented on top of the Sophia SIP stack. And so Webrtc users do not see SIP at all. They just talk the Janus API. There's no transcoding involved, and that's true for most of the plugins that we have, because we wanted to keep things very lightweight, which means that if you want to have then transcoding involved at any point, you should have that handled by a separate component in your own SIP infrastructure if needed. In general, Webrtc endpoints support ULO, ELO, and Opus codecs, which are usually more than enough to always get the communication working. But if you want to have transcoding involved for any reason, then you have to take care of that on your own. And we chose that way mostly because, in our view, it simplified life for web developers, most of whom do not have a great experience with SIP in principle. So they do not also want to worry too much about the SIP, handling a SIP stack on themselves, handling the SIP life cycle of a call and things like that. And so we basically just have some basic methods and events to handle a call. So you can say, I want to call this SIP URI. I want to answer a call coming from a specific SIP URI and things like that, a call that's just being hung up and things like that. We allow for some headers injection in case somebody wants to, let's say, has some more custom scenario that they want to handle and they want some specific headers to be present, let's say, in the invite that they are going to send. But apart from that, users on the web end really do not ever see SIP at all, which may or may not be something that you actually want, because of course you may not want life to be that simple at the web side, because you may want to have more control for different reasons for that. Maybe because you want to just reuse some existing stacks that you've been using so far. You want to have more control of the actual management of the SIP calls. You do not like Sophia SIP, or whatever kind of reason that there could be. And in principle, as I said, the existing SIP plugin doesn't allow that. And as I've said, we hide those details on purpose. And we expose some partial control to, I already mentioned some of these things. But the cool idea is that, as I mentioned, Janus is extensible. So nothing prevents you to actually write a new plugin that handles these requirements in a different way. So if the stack is the problem, you may write, for instance, a new plugin that uses PJZip instead of SophiaZip or things like that. Or as Saul Ibarra-Corregge recently suggested, we may use an approach that is called boring SDP, where you actually, you actually do not involve zip within the plugin itself, but you only involve Janus for the, let's say, for the setup of a non-Webrtc SDP that then you can use within your own zip correlation. And so the idea is that you only leave Janus to handle the media gatewaying, so that you have both the Webrtc SDP that the browser has created and the SDP that Janus has made available because it created, let's say, some kind of a relay on your behalf. And then you handle all the zip communication on your own, within your own web application. And so you may choose which one of the two to use. You may do that at an application server level or at the browser level. You're pretty much free to do whatever you want. Of course, this is something that doesn't exist yet, but this is something that we want to do in the future. And this is just to give you an idea of the different ways that you can actually interact with zip from Janus. And these are not even all the ways that you could do that. I mean, somebody may come tomorrow and propose an even more cooler idea to do that. I would be really open to something like this. At this point, you may be also wondering if all of this that I've been talking about so far is actually being used by somebody or if it's just all theory and stuff like that. And of course, we are using this a lot because at the beginning, we started working on this for ourselves because we had some really specific requirements, which at the time was making our web conferencing product Webrtc compliant because it was already zip compliant and all kinds of things, but we wanted to move to the Webrtc world as well. And we are using this a lot for, like, more in general, for making Webrtc web conferences and webinars and things like that, for Webrtc To Sit Gateway features, because our audio endpoint is still audio zip-based, and more specifically, we're using Asterisk and ConfBridge for the purpose. And we're also using it a lot for the streaming of live events. So one of the examples is the ITF meetings, and I'll show you some examples later on. But it may be more interesting to show you how actually other people are actually using this in more funny and creative ways. And this is a non-exhaustive list that shows you the wide range of context of let's say, real-time multimedia applications that people are starting to use this. So from more traditional scenarios like e-learning, co-working, contact centers, and so on, to more complex stuff like surveillance systems, e-health, even involving stuff like mobile devices, Raspberry Pis, drones, and things like that. And one more cool thing about this is that some third-party tools are also starting to come out, and not only from the modular approach that I was describing that allows you to write your own module to do some things and extend Janus itself, but also just by the controlling Janus perspective. Because as I said, you may want to talk to Janus directly from the browser, but in most cases, you may want to have your own application server talking to Janus, and so having Janus mostly as a media server that you can control your own way and then handle the communication with users your own way. And this is possible, and of course, some people have already provided some stacks to control Janus from different frameworks like Node.js, Java, or .NET, and these kind of things, and these are all useful resources. And so just to fly a bit on the last slides to show you a bit of some examples, this is an example of how we do the streaming of the ITF. The ITF has always 8 tracks in parallel that are happening pretty much like this one. This would be a track in the ITF style. And so pretty much as it happens here, we have a camera in every room, and we are capturing the signal from the beamer at the same time. And both of these streams are actually made available to the streaming plugin because we do not use a Webrtc endpoint to capture those. And this is an example of our control application because we can't, of course, be in all of 8 rooms at the same time. We have to basically be somewhere and be able to control whatever is happening, maybe follow the camera around if people are moving too much and things like that. Or also just figuring out if there are any issues that we need to take care of. So for instance, audio stopped working, a webcam froze, or whatever happened that actually needed our assistance for some reason. And this is all Janus-based because these are all streams that are handled by Janus, and we so implemented a web interface that allows us to control this in a timely way. While users instead would see an interface pretty much like this, which is very similar to most of the conferencing platforms that you probably used in the past. And more in particular, as I said, there are 2 different streams that are handled by the streaming plugin, and the other guy that you see there instead is a person that was presenting remotely from his car, I think, in that case. So using the video room plugin instead. And for the audio part, as I mentioned, we are using the SIP plugin. So in that simple screenshot, you actually see 3 different plugins being used with each other in order to create a single application. And if you didn't know the fact that there are actually plugins involved, you wouldn't even know about all of this complexity in the back end. And all of these streams can actually be also recorded and post-processed later on, which is what we do for IETF meetings. And so for all of the IETF sessions, we actually post-process the recording, handle all these streams that have been captured and recorded, and then maybe generate a video that can be pushed to YouTube or whatever other service. To come instead to some of the creative ways that people are using it on their own, the first one that I always show is this cool demo by Tim Panton and Neil Stratford, who actually created their own plugin to control a parrot drone. So they use the SDK to control the parrot drone via data channels. And then they would basically feed the video from the drone back to Janus in order to make it Webrtc compliant, which made for a really cool demo. And there's a YouTube video that shows you how that worked. It basically allowed you to control this remote drone to a web interface because you had the data channel that was actually acting as an intermediary between you and the SDK in order to do all this cool stuff. And during the Matrix presentation before, we've also seen that for the Webrtc part, for the drone control and the drone demo that they had before it crashed, unfortunately, they were using Janus as well, which was really cool in our perspective as well, because it showed that Janus could actually also be used in conjunction with such a cool framework. And there are also a couple of videos where they show how they actually won a competition for these and how they were actually capturing the video coming from a drone. So coming instead to some more traditional scenarios, this is an open source project by the OpenSUSE developers. And they called it Jangouts, which is a really cool name that stands for Janus Hangouts. And they basically have created a simple front end that basically tries to simulate the way that Hangouts work, but using Janus alone. And so they're using, of course, Janus for audio and video, but also for the chat part, for sharing files and so on, using data channels in that case. There's also a CPEX MPP application server made by AG Projects, which is called Silk Server, and they're also using the SIP gateway in particular, the SIP plugin in Janus to actually interact with their own framework from a Webrtc endpoint. This is more recent news and something that I didn't know before I actually read about this myself. If you look at those 2 blogs over there, you'll see that they found out that Slack itself is using Janus as a means to create multi-point communications within their room. I think only for premium users at the moment. I'm not sure about that. There's a cool e-learning platform by Lenovo, which is called Their Class, which also uses our Janus platform for implementing all these kind of features. There's a couple of team co-working applications by cool people from San Francisco, which are Squiggle and Speak.io, and they both are using Janus for their features. One using the video room plugin, and one using the video room plugin and the audio bridge plugin at the same time in order to create cool stuff. And finally, this is another framework called Veeting that allows you to do business conferencing in different ways. So this is, again, not an exhaustive list, just a list that I wanted to show to give you an idea of how different ideas could actually be handled by the same component in the back end in a more or less creative way using whatever is available. But then you can also extend it to do other things if you wanted. And so just to complete, I mean, there may be some more things that we need to do. Of course, at the Webrtc implementation level, we have to do better renegotiation, multi-stream support, and things like that. We want to keep on improving things because, of course, it's a moving project. And more recently, we also want to work on a new kind of modular approach, which is the events-based API. And this is a cool idea that came up also with the discussion with Lorenzo and Alexander from the SIP Capture team, because we basically wanted to have a way to interact, to let's say, have any kind of SIP management within Janus to also be known and available in a Homer kind of setup and so on. It could also be useful for, let's say, live stats collection via tools like CoolStats.io and things like that. But you may also write your own plugin to save to DB, to send to an external service, to do whatever you want. And this is something that we want to start working on as soon as possible. And I mean, the main thing is that, of course, the more you play with it, the more ideas we get back, the more we are actually able to improve all of this. And so, just to conclude, this is a very shameless bragging. I won this nice cup in San Francisco a couple of weeks ago, exactly for a presentation at the Pitch Fest on Janus, which was nice. And I hope I managed to be to keep on in my time slot, and I hope there will be time for questions if anybody has some for me. Thank you.
Okay. Thank you.
Just a question with regards to going between Webrtc and SIP. We learned from Ula that Opus really needs the RTCP feedback events, and no plain old SIP device can generate them. Can the gateway generate feedback events for the SAPPF leg?
We currently, as far as RTSP is concerned, we handle it in two ways. For some, we actually do handle we actually terminate RTCP itself, for instance, for receiver report and sender reports and things like that. Others instead are just forwarded to the other end, like for instance, any kind of request for a keyframe and things like this. So we haven't investigated more in detail the specific feedback that can be useful for the Opus mechanism, for instance, and any kind of also information like forward error correction and things like that. But in principle, if it's just, let's say, relying on basic RTSP statistics that you can use in order to figure out whether or not the Opus management needs to ramp up or slow down and things like that, this is all possible within the plugin itself.
Other questions? I saw here. Go.
Yeah, since the discussion is about Opus now, I just wanted to say that there is no specification on when actually to increase the bitrate or decrease it, right? So you have to kind of figure out these thresholds for yourself based on packet loss and jitter or...
Yeah, no, I mean, and this is why I mentioned this is also something that we can do because, for instance, we can even if you do not want to rely on the internal specifics of the library itself, you can actually manipulate these things in a more or less dynamic way yourself with some knobs and things like that. And you can actually get these if you get some feedback where there is excessive packet loss and so on, and the endpoint is smart enough to handle it, then it can actually tweak these things on your behalf. So.
To add to that, there's a lot of work going on with RTP congestion algorithms. So in addition to RTCP, there will be other feedback, and I haven't looked at the specs for a while, but there will be feedback so you can actually handle congestion situations and draw back as well. This is really, really critical for video, but of course it's critical for audio as well with Opus. Yeah, but the starting point is the basic RTCP feedback. If we can get everyone to do that properly, we can take the second step later on. But what you're looking for is RTP congestion control, and there's a lot of documents out there on it.
I see your point. And for example, we can go to minimum bit rate and then increase a little bit because Opus supports like 400 bit rates. And yeah, you need something smarter than just figuring out things by hearing what's happening.
Yeah, and I think at the moment, I think the REMB, for instance, mechanism is only available for video. I'm not sure it's only available for, it's also available for audio, but
I think it's generic.
It should be generic. Yeah, I haven't checked it for audio-only codes.
Mostly, but I think the control is just RTP control.
Okay, then thank you, Lorenzo. Thank you for